I will be talking about electron microscopy. So, from my experience, microscopy and spectrophotometry, these are the two um, topics which are extremely important, where you will 100% you will get questions, or not 100, at least 90% chances that you will get good questions over there. So these are the two topics. Please read them very well. Okay, I will take up electron microscopy now. Is it visible? Na black আসছে? Visible?
Yes, sir.
Okay. Hmm. Okay. So electron microscopy. Only difference, the major difference between electron microscopy and the light microscopy is that instead of light, you use electrons. Electrons give a better resolution, not magnification, resolution. I had talked about important question is difference between magnification and resolution. This can be a question. Okay. So we'll talk about transmission electron microscopy, scanning electron microscopy, uh, how you prepare tissue for electron microscopy, and what are the uses of electron microscopy. So light microscope was introduced and everything was fine. You know the story of Antony van Leeuwenhoek and then Robert Hooke and all these things. We know these stories which have taken place. So in Van Leeuwenhoek's microscope, the limiting factor was the single convex lens. Convex lens, this is convex lens. Concave lens is this. So this was the limiting factor. Magnifying glass type. So then compound microscopes were used. Compound microscope actually uh, used a system of lenses, not one lenses. So simple microscope and compound microscope. Simple microscope used one lenses, and a compound microscope used many lenses. So in sufficient light, an unaided human eye can distinguish 2 points, 0.2 millimeters apart. If they are 0.2 millimeters apart, you can if your eyes are good and you have sufficient light, you can distinguish between 2 points, and that is the resolution. When you use a lens or an assembly of lenses in a microscope, you can magnify this distance. So this distance can be between 2 points can be magnified. If it was like this, it becomes a bit more, and this enables the eye to see points even closer than zero point 0.2 millimeters. So you are able to see, but when you increase the magnification, the distance between this becomes very much pixelated, becomes blurred. So you have optical microscope, which you have seen, and then you have charged particles, which we are using, and that is electron microscope. They used a beam of electrons, and instead of glass lenses, what you have is the lenses are nothing but electron condensers. That is an electromagnetic field which will move the electrons right, left, up, down. So it's like you don't have a something like a, glass through which electrons flow. You have a surrounded by an electromagnetic field, and this field generator is the condenser, and that actually condenses the electron beams and makes it behave like light. That light microscopy, and they can see features as small as tenth of a nanometer, such as individual atoms can be seen. At least molecules, large molecules can be very clearly seen. Protein molecules can be very clearly seen. So a light microscope can modern light microscope at the maximum it can magnify 1000 times. And then using light with a shorter wavelength, there is a small improvement. If you use oil immersion, you immerse it in oil, the lens and the sample in oil, then up to 100 nanometer you can actually resolve 2 points. So wavelength is of electron is 1 lakh times shorter than that of visible light. And electric and magnetic field are used to shape the paths followed by electron, like I told. Electrons also travel in straight lines, and like light, they have got wave-like properties. They behave like light. Instead of glass lenses, you are using electric and magnetic fields to it acts like lenses. So Ruska was awarded the Nobel Prize for this electron microscopy. So today electron microscopes have got a resolution better than 0.05 nanometer, 100 nanometer থেকে 0.05 এতে you are going more than 400 times 4000 times better than a typical light microscope, and so many times better than unaided eye. So this is just why you what is the resolution limits of electron microscope. You have seen that it is very small. So, and you know the resolution of a microscope, how you distinguish between 2 points, not magnification. You can magnify, but it will become blurred. But then, how you can distinguish 2 points clearly, clarity. So, you know the formula. This is the same limit of resolution. You know what was numerical aperture. In my last class, I had talked about this. The wavelength of an electron beam is 100,000 times less than that of visible light, and hence the resolution of an electron microscope is far superior to that of light microscope. So, light microscopes, you have light photons. Here, photons are substituted with electrons. Glass lenses are substituted with electromagnetic and electrostatic lenses. And you have electron microscopy done. So you know that atoms are made up of protons, neutrons, and electrons. Electrons are 1,800 times lighter than nuclear particles, and they also, they have occupied distant orbits and orbitals, and each orbital or orbit has got a fixed amount of energy. So they are in an energy plane of fixed energy, high energy, low energy. So if you give it energy, an electron goes from a low energy orbit to a higher energy orbit. Higher energy orbits are on this have got are more unstable. So when electrons are liberated from the atoms, when electrons are relieved, that is they have got much more energy. Then they behave like light. So you're basically two types: transmission electron microscopy and scanning electron microscopy. So let us look at how this basically this electron micro the light source condenser. This is the light microscopy. Condenser lens, specimen, objective, eyepiece, and you see it in the eyes. Here you have a heated filament, which is the source of electron. You have an electromagnetic field that condenses this. Then the specimen is there. The electrons pass through the specimens. These are the objective electromagnetic lens. And then you get an image on a screen. So these are not lenses, but a surrounding magnet, electromagnet. You surround it in a tube, and that actually moves the condenses and influences the path of the electron. So this is the transmission electron microscope. And scanning electron transmission microscope has got a great power. It resolves two objects very well. But if you want to know what are the surface features, কতটা এবড়ো খেবড়ো surface টা, what are the surface features, Scanning microscope, electron microscope is better. So you have this beam deflected and everything comes and it falls on the specimen. And then what happens? The electrons, one group of electron actually, it is magnified. And then you want to see whether how the surface feature is. কত উঁচু নিচু আছে। Then because depending upon the roughness or the irregularities on the surface of the specimen, the electrons are scattered, and these scattered electrons, they are detected and viewed. So because of these scattered electrons, where they are scattering, you get an image where you can know the surface feature, কতটা উঁচু নিচু কতটা better রয়েছে. You can get a scanning electron microscope. So one is for transmission, is for large resolution, and scanning is also large, plus you get a, you know this what is the surface feature, because of the specimen. Say if it is like a mountain, like here, the electron will scatter and it may scatter in this direction, and that scattered electron is actually captured. And then you can know ebro khebro kirakum surface ta, you can see finer features. Clear difference between transmission and electron microscope? শুনতে পাচ্ছ? হ্যালো?
Yes, sir.
Okay, okay. So this is how a transmission electron microscope looks like, and this is a scanning electron microscope. So under electron microscope, this is how a normal cell will look like. You don't see 1, 2, 3, 4 over there. That is has been given later, but more or less it will look very clear. So the transmission electron microscope is the direct counterpart of light microscope. It involves the passage of high velocity electron beam through specimen, thin enough to transmit 50% of the electrons. So through the specimen, you give a high energy electron beam, 50% is transmitted, and they are the electrons are focused by an electromagnetic lens to form a two-dimensional magnified image. So it's the same thing, only the thing is in light microscopy, LM, you use light, and in transmission electron microscopy, you use electrons. And you have to prepare the specimen differently. So electron gun, the electron is being condensed projector, and then you see it on a photographic plate, and here you directly see it with your eyes. Here you see it in your computer. This is the electron microscope, and then you see the image on a computer. So these are the features. Light microscope, it measures visible light, red light to violet light, 390 to 760. This is the 300 to 700 nanometer. 700 nanometer is red, and 300 is violet. And in electron, it is 4 nanometer. অনেকটাই কম wavelength, very short. Maximum resolving power 200 nanometer. Here it is 0.14 nanometer. Maximum magnification 1000 to 1500 times it can magnify. Here 5 lakh times. Radiation source, you use a bulb, and here you use a high voltage tungsten filament. Lenses are glass. Here the lenses are magnets. The interior is air filled. Here the interior must be vacuum, otherwise the air will absorb your electrons. Focus, the lens is movable, but here the lens is rigidly fixed. What you actually adjust is how much current you pass, that is how much electrons will go. Here there you the lens, you move the lens and adjust the amount of light, but here lens are fixed, but you adjust the current, kotota current, more current, more electrons. So you adjust it like this. The effect is the same. Then for focusing screen, You can see it on a photographic film, or you can see it by eyes. Here you need a fluorescent screen and photographic film. You fix it with formaldehyde staining. You can do here. You need OSO4, osmium tetroxide, or glutaraldehyde for staining. You embed your specimen in wax, in histology, where wax Pankaj sir does a lot. And then you have here you need special resins. Here you can cut sections in microtome. Here you need ultra microtome. Here stains are water soluble dye. Here the stains are heavy metals. You need glass slide here. You need copper slides here. So power cable, electron kamche, চারদিকে magnetic lenses are there. Electrons are focused. The specimen is over here. There is an airlock. No air, it's vacuum. And it falls on a specimen plate. So the electron source is from this wine height cap, or this particular tungsten lamp. And then you have magnetic lens. Then you can you have the condenser aperture. These are also magnetic. It is a thin disc with a small circular through hole. It is used to restrict the electron beam and filter out unwanted electrons before hitting the specimen. You can block the electrons. You have the condenser aperture also. You can have it. You have the condenser lens. Same like light microscopy. Then you need to create a vacuum, as we have seen. Then you have a sample holder. Yeah, this is a sample holder, a picture of a sample holder. এই যে গ্রিডের উপরে থাকে, you have these grids. On top of these grids you place your sample and place the electrons. So imaging system is nothing but you have a screen and you have the electron beams. Now let us go to scanning electron microscopy. So what happens is, from this electron gun, there is this condenser, the electron goes, the beam is deflected, it falls on the specimen, and these electrons are scattered. And these scattered electrons are measured. So depending upon the amount of scattering, you can get how tilted or how uneven the surface of the specimen is. This is scanning electron microscope. So electron beams, basically you measure these scattered electrons, unscattered electrons, inelastically scattered electrons. You measured positive ions, you measured secondary electrons, backscattered electrons, যেগুলো পেছন দিকে reflected back হচ্ছে, you measure the electron beam. So basically you get the surface features very clearly, depending upon কতটা এদিক ওদিক বেঁকে গেছে. So basically this is electron microscopy. Clear? ঠিক আছে আজকে? ঠিক আছে রুচি? Okay, okay.